we are Deevio. We are automating visual inspections. What that means is that currently the quality control before you ship a product is still done manually. So for example, all the products that you see behind me, precision tools, each of them gets checked for defects before they're shipped. And that means that 4 to 5 people every day have to check the parts, and it's prone to errors. You overlook defects and you just get tired, and it's not the best possible solution. One way to solve it is to use cameras and machine vision to install cameras and then write an actual rule-based software application that is able to detect the different defects. So basically you would write algorithms that compare the different pixels, and each different defect has to have a different algorithm. So it's very tedious and takes a lot of time to calibrate these machine vision systems. In order to catch every defect, it happens that they have a high false eject rate. That means that you rather want that everything that could be a defect is sorted out, but while being so strict, a lot of good parts that have a bit of dust on them or different other things that are not a defect are also thrown out. So that can result to that companies have to throw away 10 to 15% of their production, even though there's no defect on it. And that's what we solve. And we automate these end-of-line quality control using machine learning and compared to rule-based machine vision. What that means is that we take example images of products. So we take images of these parts behind me, of good ones and of bad ones. And together with the experts, which we're actually doing right now in a different room, we are labeling the defects. So imagine Microsoft Paint and you draw the line where the defect is. And based on that, we have developed a toolkit with which we are able to write or to develop the AI-based quality control software. This happens in a few hours, mostly overnight. And on the next day, we test the developed model with new production data and make sure that it actually works. We don't just deliver the software, but we also know how to deploy it on the factory floor. We have a dedicated hardware device that we've developed with a company in Germany based on our needs. It's the one here you can see, so-called AI box. Basically, it's a small industrial PC with a GPU inside that runs our machine learning models. So now, after we have the model and it's on the box, we can do two things. Either we develop a full inspection system, which you will see later in a short video, or we can retrofit an existing system. Especially in pharma, this is really relevant because the machine vision systems that you have there have a false eject rate of 20%. So they have to throw away a lot of good parts, and we reduce that significantly. But for now, we want to look at the integration as part of the new system. And I'd like to make a bit of a case study here where I'm at right now. So these are the products, high precision tooling that are put into CNC machines. So for drilling, for milling, these kind of parts. Difficulties that they have a high variance of the shape. So it can be longer, shorter, different diameter, and different coating. So all of these variations cannot be covered by traditional machine vision. So at the end of the day, the company uses 100% manual inspection, 3 to 4 people per day, basically results in costs of somewhere between 120 to 140,000 euro that the company only spends on quality control. They didn't have a machine vision system, so together with partners, we configured one. This is the system that we're currently installing here. You have on the left the part where you place the mill, and then it moves to the front camera. You take a picture, and then it moves back to the second camera and it takes another picture. And this is what we're going to look at now. So you have an idea on what it also takes to develop the software, to actually be able and to get the data for the machine learning model later. So here it automatically moves to the front. It's a bit slow because it needs very high precision. So now it rotates on the side. So it's a line scan camera. We have the lighting device. We rotate it 360 degrees. And with these kind of cameras, we are able to detect or to detect defects of up to 15 microns. So really small defects that normally humans do with a magnifying glass. So this is the application. On the left here, you have a screen, a monitor, where you then see the results. And I'm jumping to that again now. 1 second. Don't have the presentation anymore here. So, and then here's the result. We have 2 screens. So first on the left screen, we have one image from the front and one image from the side. The front image is okay. So we have a machine learning model that detects it. And the side image actually has a defect or has a few defects, which we are also able to detect. Now you can click on the image and you see it in big. We're using a segmentation algorithm, so we can also highlight where the defect is in the image, which makes it very nice for the customer to see and to check, to control it if the model is correct or not, and helps to improve the model even further. So all these light blue dots here, they are actually defects in the image. So this is our product in action. It's not the only use case that we had. We actually are live in a few different other industries, mostly focusing on automotive and pharma. And we are able to really reduce the costs of the manual labor. So per use case and per production line, we have savings of 45 to 60,000 automotive, and in pharma, reducing this false eject rate from 20% to less than 1%, we save them 300,000 euro per production line per year. So the use case is really strong and gives a very good return as well. Who are we? Quick word on us. So we are an AI company based in Berlin, founded 2018. We are now 13 people, and the important thing is the mix of data science expertise and automation expertise. So we can, first of all, we can get really good images, so really good data, and then we have the data science team that can develop the best possible machine learning algorithm. And all of that is the complete offering for our customers and for automating their visual inspection. We are VC backed. We are invested from WhatX, which basically belongs to Fiesmann, and we are able to announce another investment in the next few weeks. So all of it looking quite good. That's also why the pointing here. So 2 things are interesting for us. Always looking for talent in engineering, but also in sales, business development, and of course for more use cases. So thanks a lot. That's it. And yeah, if you go back to work later after the lunch break and you see someone visually inspecting something, then give me a call. Thank you.